So this is about multiplication and division in polar form now. Here we have z1 is equal to r1 cis theta 1 and z2 is equal to r2 cis theta 2. Now when considering multiplication, we have to take z1 and z2. So if you write that, that would be r1 cis theta 1 times r2 cis theta 2. Now you can take the coefficients together, r1 r2. Now cis theta 1 I'm going to expand. That would be cos theta 1 plus I sin theta 1, and then cis theta 2, it's cos theta 2 plus I sin theta 2. Now what we have to do is we have to expand the bracket. So I will keep r1 r2 here, and then I will expand the bracket. So cos theta 1 cos theta 2, cos theta 1 cos theta 2. So the second one would be plus I cos theta 1 sin theta 2. The next one plus I sin theta 1 cos theta 2. Then we get plus I squared sin theta 1 and sin theta 2. Now we can simplify this further. So r1 r2, I will take cos theta 1 cos theta 2 with sin theta 1 sin theta 2. So I squared gives you minus 1, so that would be cos theta 1 cos theta 2 minus sin theta 1 sin theta 2. Then the imaginary terms I'm going to collect here, plus we get I cos theta 1 sin theta 2 plus sin theta 1 cos theta 2. So now what we get here, cos theta 1 cos theta 2 minus sin theta 1 sin theta 2 is nothing but cosine theta 1 plus theta 2, compound angle theory in trigonometry. This bit, compound angle in trigonometry, plus I cos theta 1 sin theta 2, that is nothing but sin theta 1 plus theta 2. Again, this bit is compound angle theory in circular functions. So z1 z2 can be written in that way. So finally we can simplify this. c1 z2 is equal to r1 r2. Now this form, again it's a cis form, but the angle would be theta 1 plus theta 2. So I can say this is cis theta 1 plus theta 2, and that is the cis form or the polar form of the multiplication of z1 z2. Okay, so now we'll discuss the division. So z1 divided by z2, so this is r1 cis theta 1 whole thing divided by r2 cis theta 2. Again we will expand this by keeping r1 and r2 out. So r1 divided by r2 cis theta 1, that is going to be cos theta 1 plus I sin theta 1 divided by cos theta 2 plus I sin theta 2. Okay, now we will consider the conjugate, complex conjugate of the denominator. So r1 r2 here. If you consider the complex conjugate, we get cos theta 2 plus I sin theta 2 multiplied with cos theta 2 minus I sin theta 2, and you multiply numerator with the same conjugate plus I sin theta 1. I'm just copying this and then multiplying with the same conjugate cos theta 2 minus I sin theta 2, then close the bracket. Now r1 r2 is here. Now first of all we will look into the denominator. We have cos squared theta 2, and then we have minus I squared sin squared theta 2, so it's going to be plus sin squared theta 2 now. So in the numerator now you have to simplify. Numerator, so we have to simplify now. So what we get here is cos theta 1 cos theta 2, then minus I cos theta 1 sin theta 2, you have to be careful, plus I sin theta 1 cos theta 2, then minus I squared, so it's going to be plus sin theta 1 sin theta 2. So this is what we get now. Now what I will do, okay, now what I will do, so you can see by looking at the denominator, so the denominator is 1, sin cos squared theta 2 plus sin squared theta 2 is 1. Then I have to take care of the numerator, so I will take the real parts first. So cos theta 1 cos theta 2 plus sin theta 1 sin theta 2. Okay, so if I get plus I here, yeah, so I get sin theta 1 cos theta 2 minus here I get cos theta 1 sin theta 2. Okay, now what is this? This one again, if you remember the compound angle formulas, so this is nothing but cosine theta 1 minus theta 2, and this one is sine theta 1 minus theta 2, this bit. Now this can be written as r1 divided by r2 cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. So we have to choose a bracket here. Now this is again we can write in terms of cis form, so it's cis theta 1 minus theta 2. So z1 divided by z2 is this now in cis form. Now as a summary, this is the summary of the discussion. So we know z1 is equal to r1 cis theta 1, then z2 is equal to r2 cis theta 2, then z1 times z2, that's going to be r1 r2 cis theta 1 plus theta 2. So when the complex numbers are multiplying each other, the argument or the angles are additive, they are adding to each other, while the you know the modulus, which is r1 r2, they are multiplying. So second one would be z1 divided by z2. So then the modulus of r1, I mean z1 is r1 divided by z2. Then when complex numbers are dividing each other, the angles are subtracting. So t1 minus t2, theta1 minus theta2. So this is the summary of the lesson, and we discuss this with all the proofs.